Welcome to Lesson 44 on Anonymous Methods, Part 5. In Part 5, we're going to explore higher order functions, in particular the map higher order function. Lesson 44 is based on Chapter 44 in the textbook How to Program Effectively in Delphi for AS A-Level Computer Science. The 12 times table in the previous lesson was a rather contrived example. The next example that we will cover in this lesson explores anonymous functions procedures in the context of higher order functions. A function that takes a function as an argument or returns a function as a result, or does both, is a higher order function. Higher order functions make it possible to define very general functions that are useful in a variety of applications. For example, the map general function, which will be our first example of a higher order function, applies a given function to each element of a list, returning a list of results. For example, to apply the action of squaring to every element of an array of integer, let's say 1 to 10, we do the following. We call the map function with an anonymous function, the one that we wish to apply to each element of an array. And in this case, we want to calculate the square of each element and return it as an element of a new array that we can use for the purposes that we want squares for. So the map function will look something like this in a Delphi program. We take an anonymous function as the first argument and we apply it to the second argument, which is in this case an array of integer. Now we need to actually define a reference to an anonymous function, and we also need to define a type, which is a dynamic array. So the reference function type is a type with the name t function of integer defined as follows: reference to function, a single argument function, and function returning an integer result. Now this time we've defined a dynamic array type in a slightly different way from the previous lessons, where we used the t-array generic built-in type. This time we're explicitly saying that we want an array of integer, but we're not at this stage ready to declare the size of this array. Okay, so we're going to create two arrays, one to hold the integers 1 to 10 and one to hold the square of these integers. So our first array, an array of integer, is of type t-array of integer, which is a dynamic array, and we actually create its size of 10 elements by initializing this array at the time that we declare it. Now the second array, another array of integer, we're not going to specify its length at this stage, but we'll just have a variable which will be a reference to a dynamic array. Okay, so the map function is going to apply an anonymous function to an array of integer which is passed to it. So what we want to do first of all is set the length of a result array, which will be of the same type and will be of the same length as the array that we're passing it to. So a result variable will store a reference to an array stored in memory, in some block of memory. Now Delphi automatically creates the variable result when the function starts executing, and Delphi will arrange for this variable to have the same type as the return type of the function, and the return type is going to be a dynamic array of type T array of integer. So using an inline inferred variable declaration where the data type is inferred, we're going to range over the integer array which is passed to the function from its lowest index value to its highest index value, and then what we're going to do is we're going to apply the function f in turn to each element of the array. Now f is the function that comes in as the first argument to map, so f is actually a reference variable of function data type, and when we actually call the map function here, we're passing it a function that is going to square the value of x. Now the value of x will be the value stored in the currently selected element of the array. And then when we've applied this anonymous function, this squaring function, to the current element, we're going to store the squared result in the result variable in the corresponding element. So after doing the iteration over the array that's passed to this map function, we should end up in this result array with the square of each integer value passed into the function in array of integer. So we assign the result returned by map to another array of integer. Now we haven't dynamically sized this array. It will be just the address of the block of memory that is where the square values are stored, because another array of integer is a reference variable. So we can now write out the contents of the original array line by line alongside the contents of the returned array. So we'll use another inline declared variable I with an inferred data type to range over the returned array, another array of integer, to high another array of integer, so that we can write out the value stored in each element of this returned array, but prefacing it with the value in the corresponding element of the original array. So in shorthand notation, map applies the function f in turn to each element of this integer array, and it means, again, shorthand notation, f is applied to 1, f is applied to 2, etc, etc, and f is applied to 10. So we get the square of 1, which is 1, the square of 2, which is 4, etc, etc, and the square of 10 is 100. Okay, so if we run this program, wrong program, sorry. So we want this program. And there indeed we have a column showing the values in the original array and then the returned array. So 1 squared is 1, 2 squared is 4, 3 squared is 9. Let me just make the font a little bit bigger. So let's make it 24. And that is our first application of a higher order function, a higher order function map. Next up, Lesson 44 Part 6, which will consider the reduce higher order function. Thank you for listening.